In this video, we're going to calculate the antiderivative of 1 over x squared square root of 49 minus 36x squared. And based on what we see under the radical, that's what tells us this should be a trig substitution. So I'm going to be doing a trig substitution. And I know my trig function I want to use is going to be sine because it's basically some perfect square minus another perfect square times x squared. That tells me sine is going to be the most useful because it matches up with our Pythagorean identity. Now, I also want to multiply sine by a coefficient, and it's basically the square root of this number over the square root of this number. And we don't worry about positive, it's going to be positive. So 7/6, and you'll see exactly why that is when I sub it in. But before you sub in, always find your dx, because everybody always forgets about the dx. So 7/6 cosine of theta d theta. That guy needs to be substituted in for. Alright, now we'll substitute in. So here is our dx. I'm just going to go ahead and throw that on top for right now. So 7/6 cosine theta d theta all over. Now don't forget this x. It's going to be this guy squared. So 7/6 sine theta squared. And then under here, we're going to have 49 minus 36 times 7/6 sine theta squared. Now our integral is all in terms of theta, and we're going to work from there until the end. We'll worry about substituting back. So first thing, let's get everything squared and simplified. So we have 7/6 here, cosine of theta d theta. In the denominator, I'm going to have a 7/6 squared from that, and then a sine squared theta as I distribute that square over multiplication. In here, I'm going to have 49 minus 36, and this is going to end up being 49 36 sine squared theta. Now we can start to see why we had to do that coefficient. Those 36's cancel, and now I can factor a 49 out of there. And here, the reason I didn't multiply these out, I can cancel one of these with this one up here, making things a little bit more simplified. So on top I've got just now cosine theta d theta over 7/6 sine squared theta, and what I'm going to do is I'm going to pull a 49 out of each term here and write it as a product, and then I can pull the 49 out of the radical, which would give me just 7 because the square root of 49 is 7. This just becomes 1 minus sine squared theta. That's why we picked the coefficient we did back at the beginning, because we wanted the 36's to cancel and we wanted these two to be the same so we could factor it out and then pull it out of the radical. Okay, so this 7 times 7/6, that gives us basically 1 over 49/6, and I'm going to pull that out of the integral, and we'll flip that on the next step. That's pulling these two constants out. Here I've got cosine theta d theta over sine squared theta, and this is going to become square root of cosine squared theta, because 1 minus sine squared theta is cosine squared theta by our Pythagorean identity. Well, we take the square root of that, we just get cosine theta, which means those cosine thetas cancel out. So we have 6 over 49 out front, and now all we have left is d theta over sine squared, or if you want, that's just cosecant squared theta d theta. This is actually one of our basic antiderivatives. We end up with 6 over 49. The antiderivative of cosecant squared is negative cotangent theta plus c. Now, we do need to get what cotangent theta is in terms of x. So I'm going to go back up here and remind ourselves that sine of theta was, x equaled 7/6 sine theta. Therefore, sine theta, because cross multiply, equals 6x over 7. What we're going to do is we're going to use that to set up a right triangle, and then we'll find cotangent theta from there. So I make this guy theta, there's our right angle. Sine does opposite, so this side would be 6x over hypotenuse. This side would be 7. And we don't really need that relationship anymore because all we need is cotangent theta. Well, by the Pythagorean theorem, this side squared plus this side squared equals this side squared. Or this side is equal to the square root of 7 squared, so 49, minus 6x squared, 36x. This should look pretty familiar. And cotangent theta, then, is the adjacent over the opposite. So square root of 49 minus 36x over 6x. So we're going to plug this in for cotangent theta. So I'm going to write the negative out front. So I have negative 6 over 49 times square root of 49 minus 36x all over 6x plus c. We'll cancel out those 6's, simplify just one step further, and we have negative square root of 49 minus 36x squared all over 49x. There's our negative. And there's our, oh, sorry, forgot the plus c. And there's our antiderivative.